Here's another one similar to the previous example. Last year, a ticket provider sold 1,350 lawn seats for a concert at $70 per ticket. This year, the provider is considering increasing the price. They estimate that each $2 increase, they will sell 30 fewer tickets. Part A is how much should the ticket provider charge in order to maximize profit? So again, very much like the previous example, the way they would figure out how much money that they would earn is they would take the number of tickets and then they would multiply it times the price. So that's how we're going to set up our function. We are going to set it up by saying that the total profit, I'll just call that P, is going to equal the number of tickets. So the number of tickets they plan on selling is 1,350. But they expect that they're going to sell 30 fewer tickets with each price increase. So we will subtract from that 30x, x representing a price increase. And then we'll take that times the price. The price currently right now is $70 per ticket, but they plan on doing a $2 increase. So we'll take 70 plus 2 times x, since it'll be $2 for every price increase. We do need to distribute that out to turn it into a quadratic equation. So when you take 1,350 times 70, you get 94,500. And then 1,350 times 2x, that would be 2,700x. And then we'll take negative 30x times 70, that's negative 2,100x. Negative 30 times 2x, negative 30x times 2x would be negative 60x squared. And then we need to rewrite that in the standard form of a quadratic equation by putting it in descending order of exponents. So that would be negative 60x squared first. And then we combine 2,700x with negative 2,100x. That'll be positive 600x plus the constant 94,500. So in order to maximize profit, we need to figure out what x is at its maximum. So that means we're going to try to figure out what the vertex is, because the vertex is based upon the maximum. We're going to use the vertex formula, which is x equals negative b over 2a. So negative b will be negative 600 over 2 times a. That would be 2 times negative 60. A value is negative 60. That's with the x squared. And when you simplify that, that would be negative 600 over negative 120. And that equals 5. So what that means is that there is going to be 5 price increases. And if there are 5 different $2 price increases, to answer the question, he should be raising 5 times 2, 5 different $2 price increases. He should be raising prices $10. So if he's already selling them for $70 a ticket, to maximize the profit, he should really be selling them for $80 a ticket. Should be adding $10 to the $70 ticket price. We also should find what his profit is. So in order to find what his profit is, we're going to replace the x with the 5 that we got for x equal to 5 right here. And that will give us the new profit. So his profit is going to be negative 60 times 5 squared plus 600 times 5 plus 94,500. Negative 6, or excuse me, you've got to do order of operations first. So negative 60 times 5 squared is 25, plus 600 times 5 plus 94,500. Always do your exponents first. We knew that already. Negative 60 times 25, that is negative 1,500. Now we're doing the multiplication step. 600 times 5 is 3,000, plus 94,500. And when you add negative 1,500 plus 3,000 to 94,500, you get $96,000. So if he does increase ticket prices by $10 per ticket, he will earn a profit of $96,000, and that is part A. We need to know the profit mainly for part B. It says find the domain and range in the context of the situation. So again, the domain represents ticket increases. You are not going to have a decrease in ticket price. He's only going to do increases in the context of the problem. So the domain is going to be 0, less than or equal to X, less than or equal to, what is the most amount of ticket prices he could potentially do? So if he's getting 1,350 seats now, but for every ticket price, he will sell 30 fewer tickets. What we need to do is divide those. So 1,350 divided by 30 is going to give us 45. Therefore, he can do no more than 45 ticket price increases, because if he goes more than 45, nobody's going to show up, and he's definitely not going to make a profit then. So that's the domain. And then the range is based upon the lowest amount of money and the highest amount of money he would expect to make for a profit. He's not going to make a negative profit, so that's going to be 0. That's going to be less than or equal to Y, which is going to, or actually P, since we use P. You can use Y if you want to, but I'll use P. Less than or equal to his maximum profit that we just figured out, which is $96,000, and that is the range. So that's the first half of the lesson, is talking about how to graph a quadratic equation, how the vertex is related to the maximum values. Second half of the lesson is talking about rate of change. A function's rate of change is how a quantity is changing in respect to a change in another quantity. For nonlinear functions, the rate of change is not the same over the entire function. You can calculate the average rate of change of a nonlinear function over an interval. So I want to focus on what this is. It says it is a change, how a quantity is changing in respect to another quantity. So it's one quantity, how it relates to the change of another quantity. And that sounds suspiciously like something we've already done, and that thing that we've already done is slope. Slope is the same as rate of change. So if it's asking for rate of change, you are finding the slope. The one difference that you might see on rate of change is that it is acceptable to use decimals when necessary. Rates of change are often used as decimals, so use a decimal when necessary, because oftentimes your rate of change is going to be based upon how the other quantity, how a single other quantity changes, which means you wind up dividing the top number by the bottom number, which means you might get a decimal answer. So example number 5 is actually using a table. I've skipped example 4, but I'm going to come back to it. Determine the average rate of change of f of x over the interval -3 to 3. So remember that from the first lesson, from the first chapter, we have these brackets. These brackets represent an interval of x from -3 to +3. So what we can see over here is when x is -3, f of x, or remember f of x is the same as a y is 48. And then it also says when x is 3, because we're using the interval from -3 to 3, y is -24. So actually we're going to use these two as an ordered pair, and we're going to find the slope. So we'll do the slope formula, which is y2 minus y1 over x2 minus x1. So I'm going to use the top number as my y2. So this is going to be actually point number 2, and this is going to be point number 1. So that will be 48, that's the y value from point number 2, minus -24, that's the y value from point number 1, over the x value from point number 2 is -3, minus the x value from point number 1 is 3. So when you have 48 minus -24, that's the same as 48 plus 24. You get 72 over -3 minus 3 is actually -6. And 72 divided by -6 is -12. So what that means is that X is dropping, or excuse me, Y is dropping 12 units for every time X drops 1 unit. So that is a 12 unit decrease in Y for every 1 unit of X. Let's try another one. This one is based upon a real-world problem testing. The table shows the number of students who took the ACT between the years 2011 and 2015. Part A, find the average rate of change in the number of students taking the ACT from 2011 to 2015. So, we're doing from 2011 to 2015, and that means that the numbers we're going to be looking at is this row, and 2015 would be the bottom row. It's not always the top and the bottom, but it just is in this case as it was the previous case. So the number of students, since that's the second column, that is your Y value, and the year represents the X value. So that means we're going to take, I'm going to call the bottom my point number 2, and this will be my ordered pair point number 1. So we got some big numbers here. We got 1,924,436 minus the top number of 1,623,112. And all of that is going to be over. X2 will be the year 2015 minus X1, which will be the year 2011. And when we take the top row minus each other, we get 301,324 over 2015 minus 2011. That's just 4. And like I said, what we're going to be doing is to find a rate of change. We're finding this per year. So we'll divide the top by the bottom. When you divide the top by the bottom, you get 75,331. So that is the rate of change. What does that mean? Because that's what's part B is interpret your results in the context of the situation. So we need to give this a label. Typically, when you give it a label, it's going to be Y units, whatever they're counting, per X units. Y units per X units. So we got an answer of 75,331. The Y value was the number of students. So that means to interpret this that there was an increase of 75,331. Since it's a positive number, increase of that many students. That's the label. It was the number of students. So that's the Y units. Y units per X units, and the X units was in years. So Y units per year is how I should interpret that.